What's going on, you guys? Mr. Allen here. So we have if p of x is equal to the product of these three super dope functions, when will p of x be greater than 0? So we have the graph of these functions right here, these three linear functions, it appears. Now, when will the product of those three be positive, right? Greater than 0 is positive. Well, if all three function values, their output values, their y values, are positive, then they'll multiply out to a positive. Is that the only time that's going to occur? No. Also, if two of them are negative and one of them is positive, then it's going to be positive as well. So let's look at that. Well, when are these functions positive versus negative? We're not talking about slopes or anything like that. We're talking about when it's above or below my x-axis. So let's look at our x-intercepts, and I'm going to break this thing apart. So I've got one right here, so we'll say this right there is a section I want to look at. Right here, we've got another one. And then over here, I've got one as well, right? Those are my three x-intercepts for these three different linear functions. So over here, I've got a negative, right? I've got a negative value for my f of x function. It's below the x-axis. And the output for both my g of x and my h of x, g of x will continue, right? Both of those are going to be positive. Well, a negative number times two positive numbers is going to be negative overall. So this area right here is going to be negative, right? That's not what I want. I want it to be positive. What about in between here? Well, my f of x function is above the x-axis that entire time. My h of x function is also above, and so is my g of x function. All three of these function output values will be positive, resulting in a positive overall. A positive times a positive times a positive is going to be positive. All right, so we got one of them. Let's keep looking here. Going backwards, I guess. I don't know why I chose to go backwards, but we're doing it. All right, now in here. So in this area, I have my h of x function is below the x-axis, so that's negative. But the other two are above, right? G of x is up here, f of x is right here. So those two are above. This is a two positives times a negative situation. That's going to be negative overall. In this last section over here, on the left side here, well, I've got my h of x and my g of x. Both are below my x-axis at this point. That's two negatives. And my f of x is above. That's a positive right there. Two negatives multiplied to a positive times another positive. Overall, it's going to be positive. So how do we write this answer out? Well, I know that I want this section right here, which starts at negative infinity. So if I'm going to go with interval notation, I'm going to have negative infinity, comma, my x value right here, which is negative 2. Since it's greater than, not greater than or equal to, I'm going to use a parenthesis there, right? Because I'm not including that value. Then the other section I want is right here between positive 1 and 2, 3, 4. So between positive 1 and 4. So I have 1, comma, 4. That is it for that dope one right there. We could also write it in inequality notation. So I could say x is less than negative 2. And I would also say that it is between 1 and 4. So we'd have something looking like this right here. I prefer the interval notation, but hey, to each their own, right? You only need one of these, right? So if the answer was this guy right here, I would circle that bad boy right there. But that is an alternative form giving me the same information. Woo! That's awesome. That's super dope. That's super fun. And I hope you guys had as much fun as I did. Have a wonderful, wonderful day. See ya.